Hello, here in this video we're going to look at week 34. We're going to start off here with the product rule. Remember, the product rule is if we have the same base and we are multiplying, we add the exponents. So you'll see a lot of stuff with the same base on here that we'll be able to add up those exponents there. And some of these are a little tricky, and it's not really ones that we per se covered in class, but we'll look at a variety of different types of problems here. Now, for these regular numbers still multiply like they always do. So when I see this 3 and the 6, I know that 3 times 6 is going to give me an 18. Then I need to add exponents for the similar bases. So here I see an m with a negative 9. Here I see an m with a negative 7. So what I'm thinking here is I'm thinking negative 9 plus negative 7. When I add those together, I'm going to get an m to the negative 16th power. All right, now let's do the n's. I've got n negative 8. I've got an n with an invisible 1. That's an n to the negative 7. Now, so this page is about the product rule, but we're also going to see negative exponents come into play. And the way negative exponents works is we take it and space, and we must take the reciprocal, because we must switch spots in the fraction. The 18 doesn't have a negative exponent. It will stay right on top. But the m, we have to take the reciprocal of it. The n, we have to take the reciprocal of it. So this will be our final answer right there. And this is the same thing as that. It says that negative exponents tell us to switch spots in the fraction. Take the reciprocal. All right. Now on this one here, this one we never really covered in class. We've got the same base here, so we'd have to add our exponents. So really what we're looking to do is do h plus a 10 plus a 5. We'd add some like terms here. So really this would just be a 3 to the h plus 15 power here. Now don't worry about ones like that. We didn't per se look at those in class. All right. Here's some other ones though for us where even if there's 3 terms, we multiply our regular numbers. So we've got the 8 times the 7 there, and then we also need to multiply it by the 6. All right. All 3 of those numbers must multiply together. Doesn't matter what order you do them in. All right. When I do the 8 times the 7 times the 6, we get a 336. All right, and then now let's add our exponents. We have the same base on all 3 of those. So negative 4 plus a 7 plus a negative 4. You can add these up in any order you want. So these together would be a negative 8. Negative 8 plus a 7 going to give me a p to the negative 1 power, which means we need to take the reciprocal of it. The 336 is to stay up top. The p to the first power must go to the bottom of the fraction. We had to take the reciprocal. Okay? So then let's carry on following through on those different types. All right, so let's go down here to one like 14. We're going to multiply a regular number. I see a 4. No regular numbers here. I see a 5. 4 times 5 is a 20. Then we add up our bases. X to the power of 2, x to the power of 5, x to the negative 8. 2 and 5 makes 7. If I add 7 to the negative 8, I'm going to get an x to the negative first power. When I add my y's up, it'll look like this. So we got 3 minus 6, that's a negative 3, minus another 3, that's a negative 2. So there's our answer after we multiply our numbers and add up our exponents. Now don't forget to handle and take care of these negative exponents. All right, so this answer will end up being 20 over x, y to the 5th. All right, now not all of them will end up with negative exponents. One like 18 here, 7 times 6 gives me the 42. Then when I go to add my exponents, 9 minus 4 is 5. 5 plus that 1 is a 6. Sometimes our exponents are positive, and we just get to leave them right where they're at. Power rule. This is when if we have an exponent on the outside of our parentheses, we must multiply by all of the exponents on the inside of the parentheses. All right, so, for example, let's go to this one right here. I've got this negative 4. You must multiply by both exponents on the inside. This will give me a k to the positive 40 power and an l to the positive 20 power. That's all it is. With the power rule, multiply the exponents by all the exponents on the inside. All right, even if we don't see it, remember, regular numbers do have an exponent. They have an invisible 1. So we must multiply by all 3 of these here. All right. So 1 times the negative 2 gives me a 3 to the negative 2nd power. And I'll have an R12, and I'll have an S to the 6th power. Now this piece right here, 3 to the negative 2 power, is really saying 1 over 3 squared, which is just a 1 over 9. Right? So we could also think about it as switching this down, turn that exponent positive, just like here, squaring 3. 3 squared is a 9. My final answer has a 9 in the denominator. The R12 and the S6 have positive exponents, so we do not take the reciprocal of those. Okay? One thing to look out for, like I said, like we saw in this one, remember that regular numbers do have exponents here. Right? So if we're looking at one here like number 8, it has to go to that 2. Now remember, this is not 4 times 2. This is the exponent of 2 multiplied by this exponent. So this is the 4th power. We have a cube, and then we have an 40th power. Now, on situations like this, if we have a number to an exponent, we must evaluate it. 2 to the 4th power means 2 times 2 times 2 times 2. Right? 2 times 2 is 8. 8 times 2 is 16. 16 times 2, sorry, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 gives us a 16. All right, so this piece is really a 16. My R40 will stay in the numerator, but this Q in this negative 4 must go to the denominator and gain a positive exponent. All right. Here's the last rule that we'll be looking at in the homework, and that is the quotient rule. Important things to remember is that regular numbers still simplify like always. This 4 over 8 will still be a 1/2. Right? And then otherwise, this is us doing large exponent minus small exponent, or also switching around the negatives and then adding them, whichever way you want. All right, so if we're going to look at this, we're looking at S. A couple ways of thinking about it. You can do, right, and then know that the S to the 9th power will be on the bottom. All right, or you can think about taking this term positive, S to the 6th power multiplied by S to the 3rd power. That's the same base. Add those exponents. All right, and here with our t's, 8 minus negative 4 will give me a t to the 12th power. Or you could think about moving this 4 down, making it positive, and then adding 8 plus 4. All right, but keep in mind that regular numbers, if possible, will simplify. If they can't, then you just leave them the same. So like here on number 8, this 3 over 8, that's not simplified. It's going to stay 3 over 8. Now here we got a double negative, which means both of these will be switching. Look at the progression here. We've got g negative 9, we've got a g negative 6. We need to switch both of these. Take the reciprocal of both. So this is really a g to the 6th power over a g to the 9th power. All right, 9 minus 6 will give me g to the 3rd power. Sorry. And it's on the bottom of the fraction because 9 minus 6 leaves us 3 left over in that denominator. This one here, we've got the 8 minus the 4. You get me an h to the 4th power. All right, so a variety of situations that can happen here. So just keep a lookout for the different possibilities. Sometimes your final answer will end up being in the numerator, and that's fine. Right, like say we're looking here, one like at 15. Look at the y's first. I've got one y on the bottom, 4 y's on top. 1 would cancel from that, leaving us with y to the 3rd power. 10 minus 5 will give me that z to the 5th power. All right, that's the 3 different rules. So keep a lookout for the different types of situations. Take your time, break these down into the different components, and double check your work.